So we are also seeing about the instruction processing cycle, and so we also have the instruction processing cycle. So the instructions are being processed based on the direction from the control signals. We have two fundamental and control paths. So the instructions are being processed under the direction of control unit. So based on this, there are fundamental six steps that are basically followed. One is fetching the instruction, decoding, evaluating the address, fetching the operands, executing the given instruction, and just storing the results. So this is the basic fundamental six step that irrespective any instruction may go through. So not all the cases require to undergo all the operations. So not all the instructions are required to follow all the six instructions. So based on the instruction type, whether it is R, let's say R type or I type or J, the steps may differ, which you'd opt for. So we have seen the instruction processing consists of two main components, which is the data path and the control logic. So data path tells you, it is going to deal with how the hardware elements are going to transfer the data signals. So the functional units that operate on the data we are going to discuss, the hardware structures like your wires and the muxes, which are enabling the flow of data into different functional units, and the registers are taken care. And at last, you have the results to be stored. So storage units that store data. So typically, the registers in these comprise the data path. So with respect to your control logic, it consists of the hardware elements that determine the control signal, and that is the signal that specifies what data path the element should flow the data in. So that has also been instructed by the instruction processing. So So now we have already contrasted between the single cycle operation and the multi-cycle operation in terms of your, say for instance, your control in the data part. So first is with respect to your single cycle machine, the control signals are being generated by and large in the same clock signals are being operated on. So both your control signals and the data signals are being generated in the same clock cycle. So everything related to one particular instruction is happening in that one particular clock cycle. So that is the point that we have to understand, because that is the prime difference between the single cycle machine and your multi-cycle machine. So with respect to your multi-cycle machine, what happens is that the control signals that is being required for the next cycle is being, that is the case with respect to your multi-cycle machine. So when you look into the latency, so latency of control processing can be overlapped with the latency of data path. So your control path, though they are the different paths, so now you have the overlapping of your control path and your data path. So data path will be sending the data for the control signal, whereas your control path now will be generating the control signal for the next clock cycle. So that is the parallelism that it is offering in terms of machine multi-cycle machines. So now these are the transaction steps that you see. So if you think we can instruction and transaction, like what is the sequence that it's going to follow the following steps. So first is fetching the instruction with respect to your immediate functions, your load word or store word, that is your register type functions, your jump instructions. So how all the three categories of instructions and how what are the transaction that is being involved in the following the sequence of the steps is being tabulated here. So you would find a difference between a register type and an immediate type jump type instruction. So this we have seen. So now we will see in detail about your single cycle data part. So first of all, we are trying to consider load word as the operation, the instruction. So load word, you're trying to load. So this is your target, this is your source register, and this is what is the immediate value. One is the immediate value that we are going to move. So that is the ideology of writing this instruction. So we are going to load. So first is fetching the instruction. So fetching the instruction is that, so your program counter will tell you what is the address of the current instruction. So based on the information from the program counter, your memory address, your instruction, the data. So data over here is the instruction which is 32-bit. So this is the what you will, so machine will understand this into a 32-bit data. So that is read data. So now it is typically an instruction. So from the instruction memory, you're fetching the data. So that is if you're fetching the instruction. So that is the first step of your single cycle path, data path. So this is first. So next is reading the operands from the register file. So now you have the instructions. So instruction here is load word. So load word is taken to happen from your source register, that is S0. So source register is S0 is a register here. So it is from the bit of 21 to 25. So here 16 bits are like occupied by your immediate value. Then you have your target register, then your source register. So 21 to 25 is the 5 bits that is dedicated for the source register. So it will go from the instruction, it is going to decode this source register and it is going to find the address in the register file. So your 25 to 21 is the memory allocation. So from the bits, 5 bits data, so those 5 bits are going to be passed here to the address. So A1 is the, so register file, as we have told, it has got 3 address locations to read data, write data functionality here. Now the address is being read. Now from this, so you will understand your source register data. So is being read. What is the address of the source register? Now you are from the register file, you are able to read. So from that address, you are going to read the data. So so the data can be the operands or any immediate data also. So now this is going to hold the immediate value. Since we are performing immediate value, you will have an operation for carrying out your signed extend. So signed you're going to able to find out what is the signed immediate value. So this is a 16-bit. So your 0 to 15 from the instruction decoding is 0 to 15, which is the immediate value. So signed extend is the signed immediate value it is going to provide you. So the upon decoding 0 to 15 bits, the first 16 bits being occupied with the immediate value. So in this case it is 1. So in this case it is 1. So the corresponding value is being passed from the signed extend value. Next is compute the memory address. So in this case what happens is that you have SRB. So this SRB is always being high, going high. So this is the data path. Now your signed value is going to be arithmetic logic unit. So here the arithmetic, we don't need read and write operation. So you have an 0, 1, 0, which is corresponding to an AND operation here. So upon this, your read data, so that is your So your what is the value, immediate value, and the signed value of here is being it is add operation. So your signed integer gets added to your data that is being read from the source register. So from those values are added. This is for signature. So your signed value. So these two are being added, and the result is being stored to the data memory. So this is your control signal. So whatever is in blue line is your control, uh, is your control signal for that matter. So now upon this, you have your now upon this you have your ALU being generated, which is the result is being stored in the data memory. So now the load word has to, so the ALU result is the particular value it has to store. So from here we have the option called as, we don't have any enable signal over here, which is write enable. So it is only the reading operation, reading the data. To, so the read data after the signed from the memory location, the result is being stored in the data memory, and the value is read back, and it is written in the address location 15 to 20, your 15 to 20. So that memory bits are being occupied by the target register or the destination. So here it has been, so which is your S3 in this case. So it is stored in A3. So the value, the data result is stored in write data in A3. So it is going to write the data in this memory location. So now we have loaded the word immediate value from the source register to the destination register. So it is the operation or the complete cycle do not stop here. So after writing the value into the particular target register, what happens is that you have to increment your program counter. So the program counter we are implementing by incremented by value 4. So in this case, your current program counter address value is incremented by, so here is again an ALU operation taking place. So addition of value is 4. So it is being added, and the new program counter value is being stored here. So this is the location of the memory address. The generated value is the memory location of the next instruction to process. So this is the complete load word operation in instruction that has been so that is the load word instruction. So before I'm going to the store word, again I shall repeat you this, what is the difference, to understand the difference, because this is, and proceed with your multi cycle and your pipeline architecture. So now again getting back, first part of the instruction, you should know what is the address the instruction is being written. So that is taken from the program counter. So program counter is a 32-bit address location which is going to hold. So which is going to tell you what is the where it is being located. So the current instruction address is being located by the program counter. So based on the address, it will go into the, it will check for the address in the instruction memory set, and it will read for the data. In this fetch. So looking into the operation here, we are finding the example of load word. So there is an immediate load word from the target register. So the immediate load word, immediate value is 1, which is stored in the register S0, and it is the 0 register, and it is being it has to be written back to your target register, that is your S3. So here it is, this type of instruction is the immediate type instruction. The cycle data path flow. So first is load word fetch. So next is the based on instruction, it is going to decode. So it is going to decode into first find what is the source of the data. So the source of the data is determined by RS. So which is the 5 bits holding from 21 to 25. So it is mentioned here. So this thick line is going to be address lines. So it is going to this address location and is going to be read up. So what the data we have is 1 over here, that is being read here. Yes. So this is respect to your reading the source operands from the register file. So here it is an immediate operation. So you have got the data. So some other case you will have the operands. So now here, the instruction 0 to 15 is the immediate operation. So it is going for signed extender. This signed value of the integer. So the signed value it is going to check and it is going to determine from here what is the signed extend the immediate. If you extend the value, what it is. So that value is being arrived over here. So next is it is computing the memory address. Your now you have the ALU operation. So ALU operation is the data and the signed value is being added and the result is being stored. 010 is typically for adding operation, the ALU control signal. So this is giving you the ALU result and that is being stored in the data memory. So here the data memory, the result is being written in this data memory. And then you have got now this understand here we have to register write is being enabled. So far when you're reading the data, this would have been this control signal would have been 0. So when you look at here the register write, so the control signal is high. So in this case, what happened? Your data, which is the result which is stored in the data memory, is read, and the data has been written in the target register, which is running between the 15 and 20. So that is the address in the register file. So S3 is going to hold 15 to 20. So and now write is being enabled. So the value is written in this data. Which is the ALU result is being written in the register file in the memory location A3. And the last step of this single cycle data path is determining the next instruction. So determining the next instruction goes with computing the program counter value. So the program counter value is being incremented by 4 in this microarchitecture. So what happens is that the current program counter value is going for an ALU operation here. So you have the summing operation done. So it is added with the value 4. So the result is again stored, is generated as a, and what is the address of the next instruction. So this is the single cycle data path for load word operation, which is going to hold 6 steps. So right from your step 1, which is going to be fetching the instruction, to the last stage of determining the next address of the next instruction. So here we will see, we have already seen what was your load instruction, how the single cycle was operational. So now we'll just understand what is the difference here. So here stored word, what happens is that we are trying to have, again this is again an immediate operation looking into the instruction. So you have here the target is T7 over here. And your source register immediate value is 44, it is going to hold. So remaining all would be the same. So apart from here, you will have, instead of here, you will have to write data into memory. So that is the concept of stored word. So here your signal will go high. There it was memory read operation. Here it is write data to your memory. So the control signal would go high here. So the data path is writing the data from the register. So that is the difference here. So the data, the source data is taken from 15 to 20. So 15 to 20 is your target. So what is the data is written back to your memory by enabling this control signal as high. So that is the typical difference between your store word and your load word. So here it is memory write operation. So from the register memory location, you're just writing it. So that is your store word operation. So here by this way, you are 44. The immediate value will be from your source register would be written to your memory, which is your write word here. So typically we'll understand the cycle path for our type of instruction, which are corresponding to your I type instruction, that is your immediate type instruction. Now, based upon your R type instruction, which is your register type instruction, we have quite small differences. So here the instruction that the operation you are trying to perform is add. So you're adding the values in the operands B and C P register. So if you recollect, we have this R type instruction coming up with the six fields. So the first field is your opcode field. Next you have the source register. Then next is again the source register. Then you have the target, the destination register. This is going to be shift amount if your operation, if you are using any shifting operation, that this will be used. Then you have your functional operands. So this is your six fields typically representing the syntax of your R type instruction. So what happens here is that first you have to understand what is the data that has to be read the data from. First we have to read the data from your RS and RT, and you have to write the ALU value in your register RD. So that is the operation. So functionally, when you look into this, so you are writing your memory to the register. So this is memory to the register. Well, baby, sir. Why? And what's the name, sir? Your name? Not yet. Okay, sir. So here, if you understand here, the additional element for this R-type instruction is that you have two registers as your source register, and you are supposed to write the value to your ALU result to your destination register instead of your RT. RT, you RD here. So that is the difference over here. So here what happens is that now you have to choose. So you are you, since you don't have any the multiplexing operation over here. Sorry, you don't have any signed immediate value operation. So you are doing it directly from the data. The data is only used. You don't have any signed values over here. So this is being 0 is the data that is being passed. So ALU SRC is being 0, control signal is generated. So it is SRC B only happening. So it is only the data that is being taken out. There is no signed value that is coming into picture here. So in case of immediate operation, this will be enabled to 1. So in this case, only this data is being taken up. And here, here again, you have the register register data, whether it is read or write. So now you have source register being read over here. So writing the so if it is so in this case the instruction is being decoded, and the source register will have from the address 11. So your this bit would be 0. So your target register is from your so it is over here. The instruction would be from your source register is from 16 to 20. So so your 11 to 15 is your destination, and your 15 to 20 is going to be your the target registers. So that is how your RT and destination register is chosen, and the value is written to your A3. So the address is being generated from your register enabling. So if it is 1, then it is the source register. So uh, uh, if it is low, it is then your destination register. So if it is your immediate operation is happening, then it is 1, otherwise it is 0. So based on this, your ALU is being performed. Here, your ALU operation is addition operation. So you have the two data to coming out from your register files, and the operation to be carried out is based on your addition here. So again, you will have the ALU control 010. So addition of the two data are being added, and the result is stored. So here it is the result is stored. The result is stored in the memory to write to the register. So the signal is over here. So it is not memory data memory, right? So it is memory to register. So this, then it is enabling this word write option. So the result is written to your register here. So the data is being stored here, but the address where it has to store, it is not from the memory, it is to the register. So the data that is computing your ALU, that is your adding operation, is being stored in your register file. So this is with respect to your single cycle operation, the difference. So you have all the other operations to carry out very similar. So like your fetching an instruction, decoding, incrementation of the program counter, all will remain the same. In between, such operations would change in order with respect to your R type instruction and your I type instruction. So next is your branch instruction. So this is typical to your jump instruction. So the branching, if you want to perform, what happens is that you have to know what is your current program counter value. So it will decode the address. So here we have to this instruction we are talking about is branch equal. So your ALU has to perform whether it is equal or not. So this is the logical operation that is taking place in the ALU. So it will look output 0. Then it is going to branch if it is going to be 1. So this is done with an stage element and operator here. So if both are 1, then you will have the incrementation of the program counter. So the incrementation of the program counter will happen to check whether it is branch equal, whether the contents of your A register and your B register are equal. So it will check if it is equal, then it will be 1. So if it is 0, it is again going to the same checking for the same the register. So computing the values of register A and R, check for it XOR operation performed. So if it is 1, then it is going to branch. So branch means you have to go to the value of the next instruction program counter. So in particular in branch instruction, you would have understood that it is in branching out to a target value. So you have the signed integer. So you will decrement by 2 value since your address is should include your signed values. So your again you have an addition operation here. So addition to your program counter value, the address. So you will be going for the signed value also. So now the new where it has to branch. So that program counter value, that is the address, will be sent over here. So this is the control path, and this is the flow of your data path with respect to your single cycle data path with your branch. So now, so this is the complete cycle process. So this is the complete cycle. So this is your control unit. So this is the blue. What the lines indicated in the blue is going to be your the control signals. The thinner lines are going to be the address, and the thicker lines are going to be your determining your data path flow. So this is a complete single cycle process operation, how it is going to look like. So we have the control signals being generated from the control unit, so which is being decoded based on the instruction. Uh, so this is with respect to your single cycle processor. This is a comprehensive view of the complete cycle processor. Okay. So if no doubts, we'll continue with the multi-cycle